Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are talking about 4.5 triangle centers. What are we going to be doing? Well, by the end of the lesson, you will be able to construct and explain the different triangle centers. Why do you need to know this? Well, understanding triangles have different points of concurrency or points of center, and how they are used in determining the distance from a point on a triangle can be used in map development. How you will know you understand it? Well, you'll know you've mastered it when you can find a point that is equidistant from various points on a triangle.
Perfect. Let's go ahead and get started. So let's talk some vocabulary. Concurrence and point of concurrency. Concurrence is when you have at least three lines intersecting at a single point. And the point of concurrency is that point in which the three lines are intersecting at. So on your notes right now, you guys have 6 pictures showing you 3 lines all intersecting. Some of them are concurrent and some are not. So go ahead and pause the video and write down or circle concurrent lines and put X's through non-concurrent lines. Okay, so hopefully in the first column you guys circled the bottom left. Neither of the middle column are concurrent, and then the two right in the far right column are concurrent. So on the two I have, you can see that these are concurrent right here because they are all concurrent because they are all intersecting at this single point, whereas these 3 lines are not concurrent because they're intersecting at 3 different places, 1, 2, and 3. So the triangle centers that we're going to be focusing on today are all going to be concurrent lines. So you will be using your compass and straight edge to do various constructions. And the result of these constructions should be concurrent lines. The first is, what is a triangle center? Well, this seems to be an easy question. It's the center of the triangle. Well, unfortunately, there are hundreds of different triangle centers that have been found throughout the hundreds and thousands of years that math has been used officially. We're going to focus on just 4. These 4 are the most common that you will see used. 3 of them are centers of very obvious things. The 4th one, it's a little bit more complicated, but it gets grouped into this category of the 4 most common ones. So we're going to go ahead and do all 4 today in this lesson. So make sure you have your compass and straight edge out along with some highlighters, please. First, an angle bisector of a triangle. You guys were constructing in lesson 4.2 an angle bisector given just an angle. Well, today you're going to be constructing the angle bisectors of all 3 angles in a triangle. Remember, bisect means to cut in half. So an angle bisector cuts an angle in half. You can see the diagram on your screen right now is showing that JF is an angle bisector, and you can tell that it's an angle bisector because of these congruency marks. Because I know both of these are congruent, I know that this is an angle bisector. So we're going to follow the construction of an angle bisector. So you guys have a triangle at the bottom of your page, and we're going to construct the incenter. The incenter is the point of concurrency where all 3 angle bisectors intersect. So with your compass, you are going to find the angle bisectors of each angle. So if you remember to do this, you are going to place your compass on one vertex. So if I start up at the top, I'm going to place my compass right here, and I'm going to open it at any length you want, as long as you are able to create 2 intersections. And then from the 2 intersections, you are going to mark 2 more arcs that are the same. And those last 2 arcs should intersect, forming a second point through the vertex, making your angle bisector. My advice to you when doing this is to create something like this. So when you do the first arc, try to keep it close to your vertex, and then when you make your second set, try to go outside your triangle just so that you don't have to do it this way, but that way you have clear, since you're doing this 3 times, you're going to have a bunch of arcs intersecting. You want to try to keep them as separate as possible. So by keeping the first arc close to the vertex, you're going to keep it away from the other two the other two angles. And by going to the exterior of the triangle for the second set of arcs, again, you're keeping it away from the other construction that you're doing. If you do everything inside all close together, they're all going to start to overlap and it can get confusing. So once you get your first one, you're going to then move to a second vertex. If I go over here, you're going to open your compass at a length that you want, and then you're going to repeat this process. And you're going to end up getting something that looks like this. So if I draw my arc here, intersecting twice, and then I'm going to go to the first intersection, and again, my advice is to open it at a distance that puts you outside the triangle. You're going to draw an arc, and then you're going to copy that same step from the other intersection. And it's going to create that second intersection you need to create a point through the angle bisector. You're going to do it one more time from the third vertex. So from the third vertex, you're going to open your compass a set length that you are comfortable with. You need to make sure that you intersect your angle twice, once, twice. And then from the 2 intersections that you've created, you're going to create 2 more arcs. Again, my advice is to go outside the triangle to keep everything separate. So there's 1. And then the last arc needs to be the same as the second one. So there's 2. And that creates a second point through the vertex, creating your third angle bisector. So we have, I'm going to go ahead and mark my angles. We know that this is an angle bisector, so I'm going to mark the angles congruent. We know that this second one we did is an angle bisector, so 1, 2. And then the third one we did, we know is an angle bisector. So 1, 2, 3, and 1, 2, and 3. Notice that all of my points are, or all of my angle bisectors are intersecting at a single point of intersection, making them concurrent lines right here.
Now it is from this point that if you place your compass and then stretch your compass out so it reaches one of your sides, because this point that we have created, that point is equidistant from each side of the triangle. So if you stretch your compass out to one of the sides and then draw a circle from that point, that circle will touch every single side of the triangle at one point. We call this circle the in circle because it is created by using the in center.
Sorry, my compass is not wanting to move how I want it to, so I'm kind of moving this around to make it show. So you can see by me putting my compass on the in center and then going around the whole triangle, we're getting this circle that is just grazing this side of the triangle, then down here, and then over here. That circle is called the in circle. It is the largest circle that will fit inside of the triangle, and because the center, the in center to the circle, so that would be your radius, it's going to be equidistant to the sides of the triangle. All right, moving on. We now have to look at our perpendicular bisectors. We've talked a lot about perpendicular bisectors throughout the course. Remember, a perpendicular bisector has to have 2 things true. It has to be perpendicular to the segment and go through the midpoint of the segment. So whatever segment it's crossing through, it has to be both perpendicular and bisected. So you can see here that JF is the perpendicular bisector of HG because F is shown as the midpoint by these congruency marks, and there's a right angle mark here showing that they are perpendicular to each other.
Now, before we get started, there's a little bit of a hint that you can use to help yourself kind of know where exactly your circumcenter is going to be at. If you have an acute triangle, then you know that your circumcenter will be on the inside of the triangle. If you have a right triangle, then your in center is going to be the midpoint of your hypotenuse. If you have an obtuse triangle, then your in-center will definitely be on the outside of the triangle. So in this case, the triangle we have here, this is an acute triangle, so we know that our our circumcenter should absolutely end up on the inside.
So we're going to go ahead and construct our perpendicular bisectors. We learned how to do this construction in lesson 4.1 when we were bisecting segments. So if you remember to do this, you take your tools, in this case your compass, and you're going to open it over half the distance. So if I want to bisect this side on the left, I'm going to open it past the midpoint, or what we believe the midpoint to be. You're going to draw an arc, and then you're going to copy that same process from the other endpoint, and you should end up getting two intersections. With your straight edge, you will draw your perpendicular bisector through those two intersections. When we were doing just a single perpendicular bisector, we kind of made that fish-looking figure. When you're doing it for all three sides, my advice is to actually not, when you're swinging your compass around, I would recommend not drawing the whole arc like that. I would actually recommend, if you know you're just going to be looking at the two intersections, you've already done this in lesson 4.1, I would recommend actually doing just where you have the intersections happening. You know the intersection is going to be somewhere over here and somewhere over here. So when you do this, you're going to kind of just estimate. But that limits, again, arcs that you don't need. You don't need this middle, like the fish body of the construction. You don't really need that. You just need the two intersections. So I would recommend you getting something that looks like this when you're doing this construction. And then again, you know that this would be a right angle, and it's a midpoint. So we can go ahead and mark it as such. Then you're going to go through and do this same process for all three sides. So that's the first perpendicular bisector. If we now go to the bottom, you're going to open your compass, what you believe to be over half the distance. Open it a little bigger because it's a longer side. And then again, rather than swinging and drawing the whole arc here, I would just do a little bit here and a little bit up here. And then I'll go to the other end point and repeat that, a little here and a little here, and you should end up creating two intersections, creating your perpendicular bisector. So we're going to go ahead and put our right angle, and I'll put two congruency marks to show we have a second midpoint. Now we're going to do our last side. So we have this side over here on the right side that we need to do still. So I'm going to take my compass. This is the longest side, so I'm going to open it even further. I'm going to swing my compass around and draw an arc up here and down here. And then I'm going to repeat that process from the other end point. A little here and a little here, and you should end up getting two intersections, creating your perpendicular bisector. So I'm going to go ahead and again do my right angle mark. And now we have three midpoints. So 1, 2, 3, and 1, 2, 3. Notice that I have a point of concurrency right there. That is my circumcenter.
Now your circumcenter is going to be used to draw yet another circle. This circle will be drawn on the outside of your triangle. Now your circumcenter is going to be equidistant from each one of your angles. So the circle that you will draw, you will put your compass at the circumcenter and then stretch your compass out to one of your angles. Then when you draw your circle going around, it should touch the vertice on the outside of each of your vertices of the triangle. So this circle basically is the smallest possible circle that can be drawn on the outside of this triangle. So when could this ever be used?
This is used very often with maps.
It is used often with maps. So if you wanted to find an area that everything would be within a certain radius of or equidistant from. But think about this.
Yes.
What if Pringles were triangular shaped? Wouldn't they have to stack them in a can?
They would.
So what they would do is they would find the circumcenter of a Pringle and then use the circumcircle to determine the size of can that they would fit into.
Very interesting, Mrs. Nets.
Hey, you know, it's math in the real world.
You're making me want to eat some Pringles.
I know. Too bad they're not triangular shaped.
Right?
Oh, well.
All right. Our next vocabulary word, altitude. Altitude is probably a word you've heard before when going to someplace high. The altitude of something is sort of like the height of something. To have an altitude, you have to be coming from a vertex of a triangle and go to the opposite side and be perpendicular to that opposite side. So similar to what Mrs. Nets was kind of talking about where the circumcenter would fall, I can show you here where your altitudes would be. Here is the vertex, opposite side, acute triangle, all three are going to be inside. If I went this way, because remember a height of something is how tall something is, but because we're talking geometrically, anything can be rotated. So if you turned your paper, you would see that this could be a height if we made this the bottom. We could rotate it so this was the bottom, making this its new height. So there are actually 3 altitudes within every triangle. With a right triangle, because you have to come from a vertex and be perpendicular to the opposite side, well, the 2 legs of a right triangle are 2 of the altitudes. The third one would be inside right here. If we measured, if this became the bottom, the altitude would go this way. Lastly, obtuse, which is what I gave you at the bottom that we're going to be constructing, because it's the most complicated. Two of your altitudes are going to fall outside of the triangle, and then the one from the obtuse angle will fall on the inside.
So much like we did with our circumcenter, it's going to be the same thing. Again, if you have an acute triangle, you're on the inside. If you have a right triangle, the difference here is it will be at the vertex of the right angle. And if you have an obtuse triangle, then it is going to be on the outside.
So you can see here I have given you an obtuse triangle, so we know our orthocenter, which is the point of concurrency for our altitudes, will fall on the outside of our triangle. I gave the obtuse triangle because it is the most complicated to construct, so hopefully doing the hardest one now, the other ones will seem easier for you. So the first one we're going to do is we're going to construct the altitude from the obtuse angle because it's the easiest one to start with. If we have to go through a vertex and be perpendicular to the opposite side, this is going to be the same as the construction we did in our previous lesson in lesson 4.4. It's the same as constructing a perpendicular line through a point not on our line. So if you remember from 4.4, you just put your compass on the point, which in this case is the obtuse angle vertex. And you're going to open it just beyond our side that we're going to be perpendicular to, and you're going to swing your compass around, making 2 intersections. And then from the 2 intersections, you create 2 more arcs that intersect, creating that second point. So you end up getting something that looks like this. So you can see here from this arc, or from this angle, I'm going to swing around making my 2 intersections. And then from the 2 intersections, you are going to draw 2 more arcs. And these last 2 need to be the exact same. So here's 1. And then from this last one is 2. And that intersection is going to be where we mark our altitude through. So here's 1 and 2. Notice that I'm both entering and exiting my triangle because we already said that there is a chance for these to fall outside of your triangle. And because it's obtuse, we know it's going to be outside of our triangle. So it's important that you draw your altitude long enough to create that point of concurrency. So this is the same exact construction that you are going to do for the 2 other angles. The problem is if I come up here to the top and I do the same process, I'm going to open my compass out just beyond the opposite side. If I were to swing my compass around, you can see that I cannot create 2 intersections. So when this happens, Anytime this happens with any sort of construction, you need to extend the side to create the second intersection. So when you do this, you end up getting something that looks like this. So with your straight edge, you are simply going to extend this bottom out further. And as far as how far, you're just going to have to estimate it. And then you can go through the process of drawing this arc. And now you're getting one, and there's your second intersection by that extended side. And then you'll come to the two intersections and do the same process we did for our first altitude. There's one, and now here on the extended side, you can create your second one, making this point right here that can go through the vertex. We know, so at this point we've created this altitude here, and we created this altitude here. So far we have this intersection point out here. So let's go ahead and make sure with our final altitude we get that same intersection. So when you go to do this, again, my first attempt at this, there's one intersection, but my second one is when that happens, you need your straight edge and extend that side out. And you end up getting, there's your second intersection. So you can now travel to the two intersections. One, let me make the same size. There's one arc. And now with that extended side, you get that second intersection to use to finish your construction. And there is the finishing touch. You have 3 altitudes on the screen. All 3 altitudes are intersecting at this single point, making that your orthocenter.
Now, there is one other way that we can find the altitudes without a compass. If you have either a right angle, some of you bought geometry kits that came with a cool little ruler that looks like a triangle, or you have just a ruler that you can use. So if you have the one that looks like the right angle, that would be the one I would recommend using. So we can kind of show you real quick what that looks like. So we're going to get out our little right deal here. So there we go. And then what you can do is you just basically put one side of it so it is flush with one side of your triangle. So for example, if we have one side, like here real quick, we're going to drag this. Yep, perfect. So now what you can do is you can slide it back and forth. You see we've got we've got one side flush with the bottom of the triangle there. So what we're going to do is we're going to move that right angle, we're going to move that right ruler, it's got a right angle on it, we're going to move it back and forth. So we're going to move it so the other side, so we can see the height of the triangle. So as we're dragging it along, if we stop right there, you'll see that the bottom is aligned with the bottom of our triangle. So let me show you where the bottom is, our bottom right here. Okay, and you'll see that the other side of our triangle is showing you where the height is. And if you'll notice, it's right along that line that we drew with the blue pen. You can do this with any of the different sides. So if you line up any of the sides with another side, and then what you're going to do is you're just going to drag it back and forth until you can see how tall the triangle is from that side. So either of those two methods work perfectly fine. Whichever one's easiest for you, that's the one you can use.
All right, great. All right, and the last one we're going to be looking at uses something called a median. A median of a triangle is a segment in a triangle that is from a vertex and to the midpoint of the opposite side. So you can see here that FJ is going to be my median in this picture because F is a vertex of my triangle and J is clearly marked as a midpoint based on these congruency marks. If you remember from lesson 4.1, to find the midpoint using construction tools, you're actually going to do the same construction process that we did for our circumcenter. You're going to find the perpendicular bisectors. With a median, though, you have to take the perpendicular bisector, which would be right here. If I have my perpendicular bisector, you then line up your straight edge with these two to actually draw the median. So we can go ahead and do this. The point of concurrency where all of our medians intersect is going to be called the centroid. The centroid is going to be where all of our medians intersect. So we're going to go through the same process that we just went through. You're actually going to see your circumcenter if you actually draw out your perpendicular bisectors.
The cool thing about your, sorry, I keep forgetting which ones we're doing. The cool thing about finding the centroid is a couple of things. Number one, it will always be on the inside of your triangle. And number two, it is the center of balance for any triangle.
Yep.
So when you find the centroid, if you were to take a pin and stick it right under any triangle, regardless of its weight, under that point, your triangle would balance.
That is true. I have center of gravity, but same thing, just so you guys know. So to do this, you are going to, if I just start on the bottom here, you're going to open your compass over half the distance. You're going to, again, I would recommend just swinging up here and down here. Repeat from the opposite side, the other end point. There's your intersection, there's your other intersection. It's going to intersect right around here. Don't forget to then use your straight edge to draw the median. So again, I cannot stress this enough. You're going to see a perpendicular bisector, but then this is your median. So that's why I have this darker so you can see that. All you need to know is that this point down here is the midpoint of this opposite side. And then you're going to go through and repeat this process for every other side. You're going to go, let's do the shortest side on the left. Open it over half the distance. You're going to draw an arc on the bottom and top. Repeat from the other end point, from here and here, and you should create 2 arc intersections. And then you're going to get your midpoint here, and then with your straight edge, draw your median. Your median is connecting this vertex to the bisected side. So here's our second midpoint we just calculated. And then the last one, you're going to place your compass on what seems to be the longest side. Open it over what you believe to be is half the distance. Swing your compass, make a mark, make another mark. Repeat process from the other end point, 1 and 2. With your straight edge, connect through to create the bisector, and then connect to make your median. So I have everything on here. You actually don't need to necessarily draw the perpendicular bisectors. You need to just make sure when you line up like if here's an intersection and here, line it up and get your midpoint. Once you know where your midpoint is, you're just going to connect it to the opposite vertex. So if I were to line up this last one we just did, if I lined my straight edge up, here's one intersection, here's my second intersection, well, I can tell that right here is my midpoint. So I can go ahead and mark my midpoint, my third midpoint, 2, 3, and then I can draw my median. By leaving them, you can see here's my circumcenter, but right here, that is actually my centroid. My centroid is what we're looking at in this case. The neat thing about a centroid, the centroid is going to break each median up into a specific ratio. Obviously, it's not splitting it in half. There's a longer piece and a shorter piece. The distance from the centroid to the vertex is going to be twice as long as the centroid to the side. So from vertex to centroid is twice as long as the centroid to the side. All right, so that is the conclusion of our notes. On the back side, on page 36, you guys have some fill in the blanks. We would like you guys to go ahead and fill them in, please, and we will go over them in class. Hopefully you guys feel confident in constructing your angle bisectors to find your incenter. Constructing your perpendicular bisectors will create your circumcenter. Constructing your perpendicular lines creates your orthocenter. And then again, finding your midpoint through the perpendicular bisector construction finds your centroid. If you have any questions, as always, please go ahead and message us on Remind or email either of us. We would be happy to help you.
Hey, Mrs. Weichel.
Hey, what, Miss Nuts?
So, why is a geometry book always so unhappy?
Why?
Because it has so many problems.
That's a good one.
No, it wasn't.
All right, thanks for joining us in Unit 4 Constructions. We will see you again in Chapter 5.
Yay!
Points on a coordinate plane.
Yes.